And people used to tell me, but Jensen, inference is so easy. Inference is the ultimate hard. Inference is ultimate hard. It is also ultimate important because it drives your revenues. And so this is the outcome. This is from semi-analysis. This is the largest, most comprehensive sweep of AI inference that has ever been done. And what you see here on the left, on this side, is tokens per watt. Tokens per watt is important because every data center, every single factory, by definition, is power constrained. A 1 gigawatt factory will never become 2. It's physically constrained. The laws of atoms, the laws of physicality. And so that 1 gigawatt of data center, you want to drive the maximum number of tokens, which is the production, the product of that factory. So you want to be on top of that curve as high as you want. The x-axis is the interactivity, the speed of inference, the speed of each inference. The faster you can inference, the faster you could, of course, respond. But very importantly, the faster you can inference, the larger the models, the more context you could process, the more tokens you can think through. This axis is the same as smartness of the AI. And so this is the throughput of the AI. This is the smartness of the AI. Notice, the smarter the AI, the lower your throughput. Makes sense. You're thinking longer. Okay? And so this axis is the speed, and I'm going to come back to this. This is important. This is where I torture all of you. But it's too important. Every CEO in the world, you watch, every CEO in the world will study their business from now on in the way I'm about to describe. Because this is your token factory. This is your AI factory. This is your revenues. There's no question about that going forward. And so this is the throughput. This is the intelligence. Better perf per watt for a given power of data center, the more throughput, the more tokens you could produce. On this side is cost. Notice, NVIDIA is the highest performance in the world. Nobody would be surprised by that. They would be surprised by the fact that in one generation, whereas Moore's law would have given us, through transistors, 50%, 2 times, Moore's law would probably give us 1.5 times more performance. You would have expected from Hopper H200, 1.5 times higher. Nobody would have expected 35 times higher. I said last year at this time that NVIDIA's Grace Blackwell NVLink 72 was 35 times perf per watt. Nobody believed me. And then semi-analysis came out, and Dylan Patel had a quote. He accused me of sandbagging. He accused me of sandbagging. He says, Jensen sandbagged. It's actually 50 times. And he's not wrong. He's not wrong. And so our cost per token, our cost per token is the lowest in the world. You can't beat it. I've said before, if you have the wrong architecture, even if it's free, it's not cheap enough. And the reason for that is because no matter what happens, you still have to build a gigawatt data center. You still have to build a gigawatt factory, and that gigawatt factory, for 15 years amortized across, that gigawatt factory is about $40 billion. Even when you put nothing on it, it's $40 billion in. You better make for darn sure you put the best computer system on that thing so that you could have the best token cost. NVIDIA's token cost is world-class, basically untouchable at the moment. And the reason that's true is because of extreme co-design. And so I'm very happy that he named us like token cost is going to keep on coming down, every single year. This is just Grace Blackwell, and then Rubin token cost will come down again, and Rubin Ultra token cost will come down again. Okay? Meanwhile, the token smartness, the smartness per token is going to keep on going up as well as we extend that curve to the right, okay? The x-axis. Meanwhile, we're going to increase the throughput. This is everything that has to be, nobody cares about tokens per second. You always have to divide it by watt. And the reason for that is because your data center is only so big. Your data center, it's of a gigawatt, you're not going to have 2. If it's 200 megawatt, you're not going to have 3. Does it make sense? And so you always have to normalize it. Otherwise, no architecture, you can compare nothing. And Moore's law was always divided by something, okay? So you have to take tokens per second per watt. Anybody who shows you anything else just doesn't understand AI, okay? Or they're trying to deceive you somehow. All right, so that's the reason why semi-analysis did it right. They did it right. Everything was divided by watt, okay? And so we're going to keep on increasing throughput. So whatever, this is the price of a token. Whatever the price, whatever that ASP is, we increase its throughput. Whatever the ASP is, we increase the throughput. Does that make sense? And then here, whatever that segment is, we reduce the cost. Whatever that segment is, we reduce the cost. So this is kind of like, this down here is essentially your segment, product segment. And that's throughput, the volume, production, and that's the cost of it. These are the two, that's why these two curves are so important. Now, I combined those two curves. You can combine those two curves if you like, but it makes your head blow up. But this curve is essentially the Pareto, and we spend, in fact, most of the world today is simply right here. This is the Hopper world. You see that? Hopper is kind of right here. Blackwell extended it and added a couple of segments. And this is really valuable, and people love that. Because the ASP difference between here and here could be 5x, 10x. Make sense? Larger model and faster. Okay? And so these are really valuable. Now, how do I see the curve changing, demand curve changing? Yesterday, I used 25% here, 25% here, 25% here, and 25%. That's all I did. But a supplier's, a manufacturer's distribution of different product segments just kind of depends. Do you guys see what I'm saying? It kind of depends. You know, Ferrari is kind of all high-end, nothing in the free tier, you know? And then somebody else, right, just depends on the brand. And I think it's going to be the same here, guys. If your business is search, you're going to be largely free tier because nobody pays for search. So if you're a search business, you're going to be largely free tier. If you're code generation, if you're agentic code, you're going to be a lot here. If you're enterprise worker, you know, and the average salary of that person, let's pick a number, say 50,000 or 70,000, you might be here. You want your product, if your customer is that person, you want your product price somewhere here. Does that make sense? It depends on your customer and the work that you do for them. It depends on the customer, the work you do for them, and the competition. Those three things matter. It's just exactly like products. AI tokens are products, a new commodity, and it'll be marketed as such. And different suppliers, different brands, different target markets are going to have different shapes. I just simply chose an equal distribution yesterday. Make sense?
Yeah, just which segment do you see is growing faster in the future?
They're all going to grow really fast at the moment. I don't think at the moment, it just doesn't matter. They're all going to grow so fast. They're all growing exponentially at the moment. Every one of them. We're at the beginning, right? The growth rate is divided by a very small number. On the vertical axis is throughput. On the horizontal axis is token rate. Today, I'm going to show you this. Because we're now able to increase the token speed, and because model sizes are increasing, because the token length, the context length, depending on the different grades of different application use case, continues to grow from maybe 100,000 tokens input length to maybe millions. The token input length is growing, and also the output token length is growing. And so all of these play into, ultimately, the marketing and the pricing of future tokens. Tokens are the new commodity, and like all commodities, once it reaches an inflection, once it becomes mature or becomes maturing, it will segment into different parts. The high throughput, low speed could be used for the free tier. The next tier could be the medium tier. Larger model maybe, higher speed for sure, larger input context length. That translates to a different price point. You could see from all the different services, this one is free, it's a free tier. The first tier could be $3 per million tokens. The next tier could be $6 per million tokens. You would like to be able to keep pushing this boundary because the larger the model, smarter. The more input token context length, more relevant. The higher the speed, the more you can think and iterate, smarter AI models. So this is about smarter AI models. And when you have smarter AI models, each one of these clicks allows you to increase the price. So this is $45. And maybe one day there'll be a premium model that allows you, a premium service that allows you to generate token speeds that are incredibly high because you're in a critical path, or maybe you're doing really long research, and $150 per million tokens is just not a thing. So let's translate that. Suppose you were to use 50 million tokens per day as a researcher at $150 per million tokens. As it turns out, as a research team, that's not even a thing. So we believe that this is the future. This is where AI wants to go. This is where it is today. It had to start here to establish the value and establish its usefulness and get better and better and better. In the future, you're going to see most services encompass all of that.
In the beginning of the market, nobody knew the technology wasn't mature, and people didn't know exactly how to use it. 100% of the early inference customers were free tier. And as the technology started to reach 01 and 03, all of a sudden, the paid tier skyrocketed because people are now able to use it for something useful. Then all of a sudden, when agents came, now, for example, Cloud Code, right? Codex, those tokens are a lot more expensive than free tier, and they're a lot more expensive than $20 a month. And so that segment, we just added 2 more segments. Did you just see that? And so this is no different than iPhone in the beginning. There was only one version, and now there are a whole lot of versions. No different than the car industry, no different than any industry. As the market expands, the segments expand. I showed a factory that is able to produce tokens of different segments and different tiers. From very, very smart, incredibly fast, to high throughput, free tier. And I described an architecture of AI factory architecture that allows you to address the whole thing to maximize, ultimately, the total revenues of the factory.